All right, week 123, building my own operating system. What is up, everyone? Thanks for checking out the stream. Yeah, I'm pretty excited about this one. We had some good progress last time with our stack guard pages, and I think we had just sort of got it working before I had to end the stream last time. So I'm pretty excited we're gonna continue with that today. And also I'm planning to work on a bit of smart pointer stuff also, because now in order to implement the stack guard pages, we implemented this custom bitmap pool last time. And I think we can make a smart pointer for this pool to handle things. So I'm excited for that. What's up, Cat Flare? First in the chat, nice to see you. Hope you're doing well. Yeah, we had some nice conversations in the Discord this week. All right. As usual, get set up a little bit. All right. Hey, what's up, Nomad? Go to his bag. Oh my gosh. Too flattering. We're at week 123, June 7th. And I was just writing down a couple things that I was planning on. So testing out the stack guard support from last time, doing a bit more in-depth testing of that. I think we only did the absolute most cursory testing, and so that's sort of a priority. Like I just said, so let's maybe recap a little bit. So anything else relevant? So let's just review a little bit what happened in the last couple streams even. So I mean, last week we were really working on this task stack pool thing. And yeah, there's a couple still allowed test that. So this one is outstanding. This is a to-do. Add unit tests. This is all outstanding. Yeah. All these cards are sort of random design decision types of things that we were working on. So not totally relevant to the work stream. This is a bit of an architecture thing. Yeah. I hate JNI in Java. Completely broke my Java OS and Linux x64 native tests. Ouch, dang. JNI strikes again. So for everyone watching who doesn't know, Catflare, aka Windows 1.0, has a research prototype kernel written in Java, which is a very interesting thing to attempt. Linux x64 native tests, that's interesting. I'm not quite sure what you mean by Linux x64 native tests. Also, what's up, Badzura44 on the Twitch chat? Thank you very much for popping in on Twitch. That's kind of rare these days. Okay, yo. So yeah, these are definitely some outstanding topics. Already sort of captured that here. Okay, let's review. Let's review and we'll choose a bit of a warm-up for today. So But first, let's read Catfly's message. I still have to work on reflection and introspection inside the AOT for ASM to maybe work. Who knows? It's all a mess made for JVMs. Yeah, that's wild work for sure to try to get Java to work ahead of time compiled in a kernel environment. All right, quick review. Let's get into it. So the goal for a while now has been to get stack guard pages working for my kernel threads. And I feel like I have a diagram somewhere around here. I think it was over here. Something like this. Yeah. What's up, Cratch 3757? What do you do for a living? Systems engineer as well. Yeah, kind of. I'm not professionally an operating systems engineer, but I work on embedded hardware in the music industry. And I do C++ programming, some embedded operating systems kind of stuff, but not kernel development yet. Yeah. Yeah, here's the concept. All right, we have our kernel threads. Each of them has a stack. Below the stack is the guard page. And all of this is in the kernel's virtual memory area. It's not in the FISMAP. This was the lazy, bad way I was doing it earlier. This is the good way. And we've implemented this. Here's how it works. So let's begin. Let me just show you, for those that haven't sort of seen things, let's start at K-main. Here's what my K-main looks like these days. I haven't touched this in a very long time because I'm not, I've sort of architected things where I'm not working on the main function. But we're in the K-main, and after a very small amount of stuff, we enter gkernel.run. Gkernel is a global object for this kernel object, and that's where things go. And then from the kernel.run, we create a single task and then start the scheduler. And that's pretty much what we're doing these days. And the interesting stuff is sort of what happens here with the scheduler. Scheduler is the primary component we've been working on for a long time now, because it is the component that handles tasks on the system. And I've been working on, kernel threads or kernel tasks. So that's, what's up, ASANs? Morning. On time today. Awesome. Columbia's 9 in the morning. Thank you for waking up at 9 in the morning to pop into the stream, man. What happened with the Cartagena outfit style? It's called the OS. Yeah, that's in the laundry. Yeah, that's in the laundry right now, but might come back. I love your kernel HPP file. This design will fuel the Java OS because OOP. Absolutely. Yeah, we're going to do some stuff that'll make the haters very mad. We're going to go do some OOP, operating systems development. All right, round robin scheduler is a scheduler that's instantiated with the round robin policy. And the scheduler is the main thing we've been working on. And the specific thing we've been working on is this part right here. Task stack pool 2. Yeah, actually, now that I think about it, we almost really didn't even finish the work last time. We just barely got to the point where the task stack pool got constructed, and then we were testing trying to write to the guard page, which should produce a fault. And we didn't even properly integrate this custom pool into the scheduler. So that is a clearly obvious thing to do. So here's maybe a bit of a plan. So one other thing to do is actually integrate task stack pool into scheduler and use it, delete the ETL pool. I think what we're going to do, okay. So the first thing we'll do is just basic verify functionality from last time. Then we'll integrate the task stack pool into the scheduler, delete the old ETL pool. We'll then do some testing of all of that to make sure it works. And depending on how much time we have, we'll start on the smart pointers. That's sort of this thing. And actually there are even some further refinements using raw storage for the pool, not an array, and also adding unit tests. So maybe this is kind of important. So there's this kind of vague cluster of work that I'm not sure the exact ordering of. What's up, Deepan? Hope I'm saying your name right. Or Deepan John. Pleasure to see how you're doing this full system. Thank you. I mean, it's really very far from a full system at this point. It is sort of the exact opposite of a full system. It's really just the bare partial pieces of a bare minimum of a kernel. But we have some ambitions. Yeah. A Sands are asking, is Sunday the only day you work on this, bro? Yeah, pretty much. This is pretty much just my slot that I reserve every week to do OS dev, and I don't have a ton of time to even work on it outside of this. So this is pretty much my time. Sometimes I do a little bit of work, but nothing interesting, only like small cleanups and cleaning up my Git history and stuff. I don't do feature development really outside of the streams at all. And Bodzor, you mentioned music embedded. I'm almost desperate enough to ask you to make me a sound module with one good piano sound. Everyone else is full of billion instruments and effects, and they cost $1 zillion. It's driving me crazy. One good piano sound. Decent sampler. Decent sampler is this pretty good piano. I think it has a good piano in it. There's also the labs piano. Check those out. All right, so let's finish the code walkthrough. So basically the idea is, right, the scheduler, its job is to implement this API, create task. A client of the scheduler should be able to create tasks that then get run by the system. And that's sort of like a key component we've been working on, is this fundamental infrastructure for just even having a task. And a task, there's a few things. And so we have the task itself, which is here. The task list. So this is where the actual tasks are stored. But the tasks also have stacks, and these are separately stored because they're big. They need to be page aligned, for example, and they're kind of special. So yeah. What's up, Grantra? Hello from North Macedonia. Dude, that's awesome. That's awesome. I've been to Skopje before. It's a cool place. One of my good friends is from Skopje. I don't know if that's where you're from, but visited. Yeah. I'm into some kafanas. Yeah. Have you ever considered allowing 3 or 4 people to work with you on this, review PRs and changes, explaining live whether you approve or not? Or it's not of your interest. It's more your content thing, but still useful for you and other devs that watch. That's a really interesting idea, Asans. I'm not opposed to it, but except I am opposed to it right now. For the moment, it's really important that my project is just very low friction and low overhead to work on. And it's also in such an early stage that it's sort of not even stable enough. Like there's so many design decisions being made right now. So it's important that I just be able to have low friction when I work on this. But in the future, it could be possible. When if there's more work to do and I sort of want to bring on more people. I mean, yeah, it'd be kind of cool to like actually make some content about how to review PRs. Basically what it is, it's like content about, it's sort of like code review, design decisions, stuff like this. To a certain extent, I already try to do this when I stream. I already try to talk about different designs I consider and then go through a process of evaluating which design I want to go for. And so I think I have a little bit of this, but it is different than code reviewing someone else's code, for sure. Yeah, you have a huge mentor profile that can result actually pretty useful for others to learn from this and from you. Yeah, thanks. Yeah, what's up, Digitalized? Nice to see you, man. Nice to see you. I will give a little bit of a shout out about this mentor thing. So some of you might know that I'm actually pretty seriously considering opening up some mentorship slots with me for anyone interested. So if you are interested in talking about that, please contact me. Yeah. Yeah, what's the best way to do that? Yeah, probably Discord or email. Yeah. Okay. All right. Yeah. Let me see. I mean, if you're interested, just email me. Anyway. So the task stack pool, like we talked about last time, it's like this custom pool allocator, right? And it has some special properties that allows it to be used for Spanish in 2 days. Hola. Right, task stack pool, custom pool. It is special because it is actually this bitmap pool that we saw last time. The bitmap pool is a pool allocator that stores the metadata out of line. And so it has the storage for the objects all right here, and then it has the bitmap allocator. Blah, 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 blah. Okay. And then last time we were seeing that I should be able to, in the test 0, I should confirm that when we try to write to a guard page, it should do a page fault. Currently I have this disabled, so let's just verify that one more time. Right, we get the panic, and so we didn't page fault. And so now we just go ahead and add this line in there, and we should hit a page fault. Page fault. So now we've basically sort of verified that the page fault is being caught and that the stack guard page is appropriately unmapped from the address space. That's awesome. Let's proceed. So what we actually need to do now is actually do the migration. So what, just for development, rather than completely replacing the old way of doing this, the M task stack pool, like this ETL pool thing, this approach was completely broken. And I only discovered that after trying it. But I had written a bunch of code that uses it. I mean, it's not like that much code, but it's like a couple call sites. Rather than completely replacing it immediately and just breaking my build, I decided to sort of prototype the new support alongside of it. And so in that way, I didn't just completely break the build all of a sudden and force myself to migrate everything all at once. I could focus on just the most important part of just sort of getting the basic new method working. Now that it's working, we can migrate everything over. And this is like, yeah, sort of maybe an opportunity for AI, but let's just see how the old task stack pool was used actually. So what it was used for is it, let's just see it in a couple places. So it's used, I think this is dead code. Init task is completely dead code. So we can even remove that. So again, back to over here. So we use it in create task. We use it two places. We use it in create, we use it to create the task stack. We allocate a task stack here. And then we actually use it to make the smart pointer. And I think that's actually it. So that's actually a very easy migration, except for the fact of the smart pointer. So that actually sort of means we need to face the smart pointer topic a little bit earlier than I thought potentially, which is not a problem. It's kind of fun. Actually, I was actually really looking forward to working on the smart pointer. So in order to do this migration, yeah, we need to, because this thing, the task stack unique pointer, well, there's a bunch of problems with this first off. And so the task stack unique pointer, it's actually poorly named and designed. It shouldn't be directly coupled to the use case of a task stack. It's really all about the ETL pool. This should really be called a pool pointer or something like this, pool unique pointer. But I didn't quite realize that when I was doing that work. And the new problem is that, yeah, we're no longer using the ETL pool for the task stack. And so we need a new smart pointer type. What's up, Wall Marcus? Nice to see you. What books and resources you are opening more than once to keep yourself on pace? Okay, these days, to be honest, I'm not really reading a lot of books and resources. I will say I do use AI to kind of talk about my OS with it and stuff, but I'm not currently reading a lot of books on OS development per se at the moment. Yeah, there's some I open from time to time, like the Linux programming interface was really helpful at helping me understand file descriptors better. But yeah. Okay, so let's take a little bit of a look at this. I'm just going to, so basically the problem is I want to migrate to my new pool, and therefore, and then I would sort of start to replace all these uses of the old pool with the new pool. And a big blocker is that the task actually requires a smart pointer to be passed to it. Right, and the task stores a unique pointer to a task stack, just straight up. So the task requires that whatever allocates the task stack is able to offer a smart pointer. Currently, our task stack pool does not do that. The task stack pool offers a raw pointer, which you need to manually pass to free. So this is going to be pretty awesome. Let's just get into it. So what we need to do is I'm just going to go ahead and duplicate this file. I don't quite know. The naming is either going to be task stack pool, unique pointer, or maybe bitmap pool, unique pointer. Aha, okay, yeah, actually, if that would kind of be interesting. If it was a bitmap pool unique pointer, then we would actually need to make some of these virtual interfaces, I think. Which, actually, as we talked about last time with digitalized, the idea was to not make these virtual, if possible. The idea was to just use simple inheritance. But as soon as we start kind of referencing things by the bitmap pool type, but then actually passing in a task stack pool, that is where we start to need virtual functions. And that's a line I'm not really willing to cross right now. So yeah. Maybe make a custom deleter for the unique pointer. Yeah. Yep. That's a good suggestion, and that's exactly the strategy. So let's just start prototyping task stack pool unique pointer. Both custom alloc free using your, maybe both custom alloc deleter using alloc free. Let's just try it. And so this is not necessarily the final form, but this will be kind of close. And so yep, so actually this is going to be, and it is a little bit unfortunate how verbose this is, but and yeah, there are probably always opportunities to refactor, but we're just going to do it the simplest, stupidest way for now, and then we'll improve it later. And so, yeah, we're using a unique pointer, and it's a unique pointer to a task stack with our custom deleter. And instead of storing a pointer to this, we're going to store a pointer to a task stack pool. Which means we need the include. And this, oh, this is, oh, dang. Oh, wait, that's ugly. Okay, that's a little bit tricky because this task stack pool is a template. ETL pool has this very useful iPool thing, which is a type that can refer to a pool of any size. I do not have this for my custom task stack pool. And it might be nice to do that, but that's a bit of a bigger blocker than I wanted to do last time. Okay. I'm just going to take a note. Actually, this requires implementing the smart pointer to do the migration. Okay. But this is a bit tricky because we don't have the equivalent of iPool yet. So for the moment, let's just see how this looks. I'm gonna see size. Okay, so now there's shit. So now this thing looks like this, which means all of this looks like this. And so this, oh, sorry, no, wait, and yeah, there we go. So now this looks like this. Oh wait, what am I doing? Wait, I see. There, T size. Okay. Right. So the obvious critique, or maybe not so obvious, but the critique I would immediately get from any C programmer is that, okay, wow, like you're making this a template type, that's going to bloat your code gen up like crazy. Because now it's going to be creating different copies of all this stuff, which would be true except for the fact that we only ever instantiate this type once. It's not really a type that's used widely throughout the kernel. But yeah, okay. And then this thing becomes, it's currently named free, but maybe we can consider a rename. And maybe just to illustrate a little bit what I was talking about with the vtable stuff. So right now, this smart pointer is directly coded against the task stack pool type. And if we have other parts of the kernel that they're not using the task stack pool, but they are using the bitmap pool, they're not going to be able to make use of our smart pointer because they code against the bitmap pool directly, and they don't know anything about the task stack pool. And so therefore, if we have other clients that are using the bitmap pool directly, then they need to, then we need another smart pointer type for the bitmap pool. And so we sort of get a bit of a proliferation of unique pointer types. An alternative would be don't hard code task stack pool here. Actually store a bitmap pool pointer or reference, and then call through that. But then, so all of this stuff is going to become bitmap pool with T and T size. But then we want to actually pass in a task stack pool in a place where we are declaring the parent class as the type. And in that situation, that is a runtime polymorphism, virtual functions sort of situation. And in that situation, you need vtables and virtual functions. which I don't want to have. That was not my intention when I started to, when I started using inheritance. I was just trying to do a bit of code reuse. So for the moment, I'm just going to go with this approach. What's up, Amangali? Why you are not using Visual Studio? I'm using Visual Studio Code, and I just like it. Okay, so now we have our task stack pool unique pointer. And let's try to do a basic migration. And so AI sort of knows. So we're no longer using the task stack unique pointer. Oh wait, it even did it do that automatically? Wait. Ooh. Okay, the problem is now that this template type is sort of proliferating everywhere. The tasks, yeah. That kind of sucks. But it is okay. Let's just see this all play out. Right. So so we're gonna we're gonna make the constructor template. We're gonna then so we can pass it over here, and then accordingly we need to make this a template also. But yeah, that. Okay, this is very interesting because it's getting out of hand very quickly, which often happens if you're using templates. Okay, this is what the naive port of this looks like. Yeah. Yeah, so I mean, yeah, it's it's not lovely, and this would be a reason to invest in the effort of creating this like iPool kind of type, which is sort of like which erases the template size. I would need to think a little bit more about how to do that. But just for the moment, we can proceed like this. And now we can go over here. And we can start trying to do things. So I'm just gonna, it's just called 2 right now for the moment. Eventually I will rename it back to 1 without the 2. But so right, everything's just named 2. So now we're calling. Okay, now the AI knows exactly what we want to do. We want to, instead of making the task stack unique pointer, it says make task stack pool unique pointer. We pass in the p task stack and point it to the pool. And then the problem is that this is a template on knum tasks. And that, right? Yeah, this function, So I don't know why it's inline actually. It doesn't need to be inline, but let's see what the warnings. Oh, the problem is there's no header. That's why. Okay, let's try to compile. Redefinition of task. It's a different kind of symbol. I think I named 2 just for now, just to get things a bit more compiling. I have a bit of a problem where I generate a lot more compiler errors than I need to because I'm doing a lot of coding in headers, which is mostly out of laziness. Okay, there we go. Makes it a bit hard to find. Okay. Having this problem. That's stack pool unique pointer. Yeah, alternatively, I just for the moment, I'm just gonna name everything 2. Yeah, this is yucky. This is going pretty poorly. So now this is proliferating really everywhere because now this thing, now task is all of a sudden a template type. Yeah, this is starting to get kind of bad. So it's almost to the point where it starts to cross a line. I mean, I could technically try to, change these things to do k num tasks, but this is just so weird. Oh wait, no, I did not want to do that. Task. It's not good because we just declare tasks so many places that just cannot be a template. So that sort of means, it sort of means we need to really look into how to make this sort of like type erased version of it, or a version of it that sort of erases the template. Which is an interesting thing to try to do. So the idea is here, we want to be able to do something like task stack iPool. And it the iPool is a type that can do operations on a pool of any size. Yeah, that's interesting. What's up, hello code? Hello, hello. Have you ever created a type 1 hypervisor? Nope. Digitalized asks, is everything still a struct to maintain compatibility with the JOS parts? No, not really. Everything is a struct because I find it kind of annoying to deal with the public and private kind of like protection keywords or whatever when I'm kind of prototyping. And structs are just nice because everything is public. But the idea is to convert things to classes once the interface is more finalized and it's more clear what that is. But I find that it just kind of gets in the way if I make things a class too early. So yeah. All right, it's been kind of a while. I feel like my palm tree timer hasn't gone off yet, so I'm just gonna trigger it now. It's been almost an hour. Let's just take a quick. Oh, wait, it appeared on the wrong screen. All right, feel free to join me. Okay. So Girish, where'd you learn all this? A lot of different places, but here's a bit of guidance. Here's my resources page with some links to some books and some courses and stuff like this. I mean, like what I'm doing right now is sort of like just the collection of everything I've ever learned. It's like things I learned in university, things I learned through my job as a C++ programmer, things I learned via streaming for over 2 years now doing OS stuff. So yeah. Okay, let's think about the iPool thing. To be very honest, I actually don't totally know how to do this. So this will be kind of a learning experience. We want to make an iPool. So let's try to just understand, even from first principles, what's the idea? So we have the pool, I mean, really, to speak very generally about what we're doing, the idea is you have some kind of class that is templated. And so let's just call it size. And then so when you actually go to use it, you do things like class 40 or class 4, class 10. You need to specify the template argument, right? But sometimes you might want to write a helper function that operates on the class. But you don't want to make the helper function a function template that operates on a specific size. You want, like when you write the helper, you don't want to have it be like class. This is sort of, you don't want to do this because what you want to do is you just want to have the helper be able to take sort of just like, yeah, like probably reference, but or reference to some kind of type that doesn't involve the template argument. And this type can just handle any kind of class that you can pass in there. Yeah. So, sorry, Girish and Rahul, I need to really lock in on this right now because it's pretty much at the edge of my ability, so I need to focus really hard. And that's what ETL pool. ETL pool is an example of this pattern. We can read ETL to understand how it implements this. We can also try to guess a little bit. My guess, it's also not completely a guess because I have read a bit of ETL as I do this. My guess is there's iPool is kind of like a parent class, and then the actual pool size inherits from iPool. And this is going to define the actual memory layout of the object based off of that size parameter. You know, it's going to do something like objects size, right? But then this is where all the functions will live here. I'm also really tempted. It's very tempting to try to use AI to do this because it probably could. But I'm going to try to do it myself first before even trying to use AI. And so the idea is like the functions will live here, and there is no reference to a specific size anywhere. Yeah, they work on pointers or something. So I feel pretty confident we could try to do something similar. What? Let me see. What I might try to do though is it would be really nice to be able to play around with some of this stuff in a unit test. Right now, I'm just coding directly in the kernel, which is not really a very focused way to do this. Like, I'm working on this one specific data type. It would be really nice just to instantiate it and kind of play around with it. And so I'm thinking about doing that. So that would be sort of the first thing. Yeah, thanks Digitalize for weighing in on some of these questions. Yeah, I need to really focus right now. So okay. Oops. Yeah, this is sort of like just a whole big mess of me trying to do some of this. It's not particularly useful. Okay. Yeah. I'm just trying to get back into a bit of a nicer space to work in. I consider a little bit of this just sort of some junk. I'm gonna stash this. So this hunk is just me attempting to port a few things over, which is where we started to run into all these problems. Then I like renamed a bunch of stuff. It's even got things to compile. And then this is also similarly, I'm just gonna stash failed ports to task stack pool unique pointer. All right, Afna, what is up? What is up, man? Yeah. All right, first order business. Let's let's just try to get this into the unit test. The way I'm going to do this, or the way we need to do this is we just need to make sure that everything here, there's no dependencies. x86 constants, kernel lib, good. The address space is also. So the great thing about this, all this stuff does not depend on hardware, and so all of it can go in kernel lib. Task stack, is that, yeah, a lot of this stuff is in the kernel. So let's just move things one at a time. And again, yeah, so right, we have kern to browse the repo with kern with a bunch of stuff and scheduler, and then we have kernel lib, which is where we can do unit tests. And what I'm going to do, I'm just going to start moving stuff. Move kern / scheduler scheduler, move bitmap pool task stack pool.hpp task stack pool unique pointer kernel lib include. Where does bitmap allocator live? I think bitmap allocator is also, oh, it's in kernel. Yeah, it's in kernel lib. So that's our first sort of thing, right? So now a bunch of stuff lives in a different place, which should be okay. And yeah, so let's just clean up a little bit. So task stack, right? Move task stack kernel lib include. Okay. So now we're looking pretty good. I'm also sort of looking at the v-address space. There is something interesting about the v-address space. The address space uses virtual functions with the vtables and stuff for a couple of its dependencies. My idea was always that this doesn't have to be that way. This can be a template. That would affect this. The nice thing about virtual functions and vtables is it makes the types concrete, which makes them much easier to deal with. Thank you, Afnan. Fundamentals of WebSockets. Crazy. I have never done that before. What's up, Bizarre Zib? Nice to see you too. Okay. Anyway, let me stop. I'm just gonna stop yapping and just keep going. So the idea is to move like everything over into kernel lib such that I can now write a unit test file. And let me try to do that. So I'm just going to go and see what's a good file to try to copy. Let's test math. I think that's a good one. So it's like a super basic unit test. And I'm going to include task stack pool.hpp. And I'm going to, interesting, right? The task stack pool, hello, has some dependent, it requires a v-address space. And so this v-address space, let's, ooh, and then, yeah, so this is like a bit annoying. So the v-address space also requires a bunch of stuff. And so technically, oh, wow, that's yucky. Technically, we need to actually copy all of this. And then technically, okay, yeah. So, so clearly quite a few opportunities to, so to be very clear, what I'm doing is not really very good. I'm copying and pasting a lot of code. Because the v-address space tests exist, but they weren't really designed yet such that other tests can have a mock v-address space. So the code is not really organized in a way that makes that easy. So unfortunately, don't copy paste all this code out of, yeah. Yeah, the more production way would be some kind of object, like a fixture object, I guess, that I can construct here that sort of already has a bunch of stuff ready to go, like the v-address space with all its dependencies and stuff like this. So, yeah. But now that I have copied and pasted all this stuff, I also need, yeah. Oh damn, wait, did I delete this from test math? Okay, oops. I'm gonna duplicate this test stack pool. And then I will delete this, okay. Cool, so we're working over here now. No. Right. Yeah, what's up, Melchi? Or Melchi Zedekamos? Dude, why are people asking for my name? Trying to dox me? All right. So that is sort of it. And so the last part would be we need to kernel lib. Wait, no, cmake lists.text test. Yo, what's up, Ray? Good to see you. So now we go over here and we add a test for task stack pool. Let me put this probably in the right place. Yeah, obviously that's my first name. All right, so we have, so now let's just do a basic build of the unit tests. These do not, oh my gosh, these do not build mock adder converter. All right. So just for the sake of being able to make some progress here, okay, check it out. We finally got the unit test building, and that's going to allow us to play around a lot more easily with the task stack pool type, but then also this this wrapper type that we want to be able to sort of have. And so, for example, what I want to do is the vision is to have some helper function, and we haven't like implemented this yet. I'll snooze the inline suggestions. We haven't implemented this yet, but the idea is to be able to take a task stack iPool and then call, for example, pool.alloc or pool.free, you know, something like this. And our job is to figure out how to actually make this reality. But once we do, we can. But just for the moment, we can even just do a basic test. Pool.outlook, right? Stack. And we can check that p stack exists. And even that can be a basic unit test. Build host. It's been a while since I ran. But yeah, also what am I doing? Because I have my helper utilities. Actually, also, do I have my testing extensions set up? I think I don't. That's unfortunate. I think this might be why. I need let's try this. Build slash, yeah, target or host. This is whack. I'm just going to that build slash host. Let's try that again. Please work. What? Oh, yeah. Kernel.
just because it's sort of nice to have this in the IDE. There we go. I don't quite know what made that work, but now we have the nice ability to do this and run some tests in like just right here. So call this task stack uni stack pool. Yeah. Yeah, I could have this all like tricked out, but okay, cool. And so now we can, for example, we can make the test fail with like a stupid stupid test, and then this thing fails. So so we officially have our yeah, our place to do this. I'm sort of thinking about how it is actually kind of interesting that the V space is calling unmap in the. I think that the chat's popping off, and I just haven't looked at it at all. But I just really I've been trying to focus. So the V, it's actually interesting that the V space is getting called. We are in the unit test, and it's trying to unmap some of the pages. But we're using, like, that's all mocked out. So I'm just gonna put that as a to do right now. It's not that important. Happens when V space unmaps the guard page with the mock the adder space sort of thing. Anyway, okay, so we're here and we can do some stuff like pool.free p stack. Yeah. For example, like a super basic test we can just do is that, how about this? We can get p stack 2, then check that p stack is equal to p stack 2, for example. So we allocate a stack, we check that it's there, we free it, and we allocate it again, call it another stack, and it should be the same one as before. And that passes. So that's not completely related to what we're doing, but it's just trying to get this scaffolding set up so we can do some development, almost a bit TDD style. And now that will allow us to begin. And so I'll just make got task stack pool harnessed. Okay, so now we're in a much nicer and more comfortable environment just to sort of do some dev directly on this type, and let's begin. So the idea I don't know what it's really going to contain, but the idea, we know for sure that it's not going to be a template. Class.
Yeah, this is very interesting, kind of challenging, because also we are already inheriting from this. Maybe just as a bit of an example, let's just sketch out. Let's just sketch out something unrelated to like this stuff. Like let's just go with like a pool. Like let's sketch out a very basic version of what ETL is doing, and let's just say object, right? This is this type, or maybe let's just make it int or something like that. Very, very simple. So I'm just going to pull in include array. Let's just say with this pool, we're just trying to do an int size objects. So that's the typed version, and then we want to have this struct iPool, and it's going to have some stuff in here. And the let's say the pool inherits from the iPool. I believe this is the pattern that ETL uses. And I think the idea is that the iPool just kind of operates on some kind of generic memory space. Let's imagine some operations, or maybe we'll make it a vector, just to make it. No, that doesn't work because it's the size thing. Okay. Ray, still having issues with the ETL? Not exactly. So what happened was, well, actually, yeah. So originally I was trying to use ETL. I ended up having some problems with ETL, which made me implement my own custom replacement for the ETL pool. I implemented this custom task stack pool, and that was going really great until I forgot that I was relying on this one feature of ETL where you can have, it's like you have the pool, which is a templated class on a size, and you have the iPool, which can operate on any kind of instantiation. I have not implemented that like iPool concept for my custom pool. And it turns out that's actually kind of important for implementing the smart pointer. Unique pointer. I was pointer, for example, here, actually very heavily relying on the fact that I could have this type erased pointer for the smart pointer. And so that is what is causing me to see if I can implement my own version of this iPool concept for my custom pool. And it is actually sort of difficult and sort of pushing me to my limit right now. I'm sure it's not that hard, but so the idea is we have some operations on it here. Any plans to use C++26 contracts? To be very honest, I'm actually not that familiar with C++26 contracts. I'm not so much following all these super new language features. So you might actually know more about that than I do. So 26 yeah, what? Yeah, maybe you could even explain. Yeah, I know concepts, but that's not what you're talking about. Contracts, yeah, I would need to learn more about that. And so with iPool, let's just imagine that we have some methods like, yeah, like let's say we want to alloc or something like this. And let's, okay, yeah, m index equals 0. Let's imagine a really, really stupid data type where you can sort of just like push things into a container and then you can't ever free things, and once it's full forever. And it's just this weird container. The point is just to make a very simple container which I can use to prototype the idea of a fixed size type and then a templated version. And so the idea, or let's just implement this over here first off, and then we can try to break it out. So the idea is like we like try to alloc, or yeah, we're gonna pass in int value. This is gonna be like really assertions without the C assert header. Oh, interesting. Do I have assert here? Just because I'm always in the habit. I'm just going to, right? So I'm a little bit embarrassed, but yeah, the thing sort of knows what I'm trying to do. Except it's not really an assertion. It's more like if m index, we're just going to return, right? This is bad. Return -1 and then return 0. So this is like this weird ass type where you can, it's more like you can push. It's this weird ass type where you can push values into this thing a certain number of times until the thing is full, and then that's it. And after that point, it starts to return an error code. So it's this super weird type. But the reason I'm doing this is because it illustrates just enough of what I need. It illustrates a templated fixed size container that has some kind of operation that operates on the container. And this will be enough to weird pool. So you have a limit. Yeah, so that's the idea behind a lot of what I'm doing, pretty much all of what I'm doing, is I'm using these fixed size static containers, which is a bit more of the embedded real-time OS, like firmware style of programming, where you don't use dynamic allocation, but you reserve memory up front. Yeah, so for the moment, I'm going to actually just get rid of this. And I'm going to make my pool, and the whole point is to have a template argument. And then I'm just going to, yeah. There we go. The AI knows exactly what to do. So this is like this really weird ass type, but now we can, yeah, that works. Just to see it fail, because you always want to see your tests fail. That fails, right? Cool. So, I mean, we can even make it smaller. We can call it 2. Right. Run current, run test at cursor. Yeah. Okay, so we have our officially weird pool tilts all right. I apologize. I actually don't even get that reference. If it's a movie reference, I'm not your person for that. Okay. Cool. So now that we have our weird pool, we can think about how we would do things, and I will just make a temp. I'll just stage that for now. And so now the idea is we want to conceptually have this be over here, and we conceptually want something like that. And I think I have an idea. So the way it's going to work, the more general concept here is we just have some objects and some storage. Right, yeah, so the idea is, so the idea behind the static allocation thing is reserving memory up front, and so you can very easily reason about how much memory the system has, and reason about the maximum worst case memory usage. And you make some trade-offs when you do this, but you get some advantages. You get a system that's simpler to understand because you just know up front, okay, there will only ever be 100 tasks. There will only ever be this many things, this many things. And so this is sort of the way the firmware engineers design things a lot of the time, which differs from more like desktop or other kinds of programming, where you just use these dynamic containers and you don't really think a lot about like maximum memory usage per se. And I'm not saying one is better or worse. I'm just saying I'm interested in learning about more of this firmware style of development. And then this concept of like having the operations be kind of abstracted away from the concrete thing is a very useful thing when you're doing development in this style. So I'm just gonna make a guess at how I think this is gonna look. And I'm just gonna have some constructors over here just in case, but I sort of let's see, what about this? We're trying to sort of like convert a lot of this info away from template arguments and into like actual arguments. So what if we could do something like really strange like this, right? This is partially from my memory of like having previously read ETL, but I'm trying not to go and look at the answer. But like, what if we could do this? So, actually, what we've effectively done is created sort of like a weird span, actually. But to avoid getting very fancy with it right now, let's just try sort of like this. So, or maybe even to do a bit of TDD. We can even, this is actually a great opportunity to do some TDD. Section, basic usage. iPool. And so the idea is to have the pool and then we have the iPool. And you can construct an iPool. This is currently how we do it. But this is sort of the vision, I guess. But really this is not really the vision. The vision is to actually construct the iPool directly from the source object. I wonder, does this work? So, yeah, I think this is sort of the vision. It's a Rudy Ling. What have I missed in the last 3 weeks? We've just been doing lots of stuff. Stack guard pages, which is involving these kind of custom pool allocator type, which I made, which I've realized has kind of like a major missing feature. Would a diagram help? I think, yeah, when I sort of understand, I think, yeah, eventually we can make a diagram. So now we sort of have this weird problem where okay, let's try a different thing. I think we can be a bit less fancy with it. So, I mean, even without even this. So theoretically, this is not a very convenient way to construct the iPool, but in theory, it's basically a span that just takes a non-owning view of the data and then sort of works with it. And so then like the current index goes here, for example. This thing is M size. And then this thing, it's sort of like P start, basically. And now we've basically converted this logic into a more generic kind of implementation that can now operate on containers of arbitrary size. So this code has now become officially decoupled from the actual size, because we're no longer using this template argument everywhere to declare the type and do the logic. We are actually storing it as a member and then just using a pointer. And let me so I'm just gonna call this push. I'm gonna call this push 2, or maybe or maybe I'll just, it's sort of like generic push or something like this. So now over here, generic push. And I guess actually, we don't actually need the inheritance for this. Okay, for this iteration of it, For this iteration of things, iPool is just a like view type that gets sort of like this non-owning lightweight wrapper view over something, and then has some operations it can do. So actually the inheritance was not even necessary for that. Maybe it becomes necessary later. And so what we can do, no member named p start, I see. So this is p m objects dot data. And this is interesting because there's no size, and so it's sort of just like two. I mean, and how do I actually using size equals size? No, I think I'm not doing that right. I think, yeah, I need to ask the AI for help here. Can I store the size on the class so I can reference it like pool size? I hope it knows what I mean. The static const expr way. Or no, or yeah, but it also, yeah, the array actually has it. So, yes. So either way, but actually, yeah, I could do object dot size, and m object needs to be renamed to m objects. Okay, cool. So, yeah, Rahul, thank you for calling me out on my violation. Right. Okay, so these tests pass. Just to verify things, let's just break the production code and see the tests fail. So something seems okay. Here we go. Good. So now I broke the production code. Now the tests are failing. So we really, yeah, that's interesting. So this is sort of like the basic MVP, right? This is sort of like the most minimal version of doing this. And what we've sort of done is we have this core type, then we have this type that implements a wrapper over it and implements some of the operations. And then now what we want to do is sort of unify things though, because now like this, we have this push thing and this thing was over here. We pretty much only want to have this one. And so now the idea is like, well, okay, how do we, because we also want to be able to do p dot, I guess generic push is sort of like the name of the API at this point. So we want to be able to call the method both on p and the iPool. And this is where the actual inheritance starts
to become useful, because like so what we want to do, we basically want to make this type only used to even this m index is not really necessary anymore. The purpose of this type is pretty much solely just to declare the data with the template argument. Everything else pretty much goes into this thing. And so now when we make this inherit from iPool, now the pool type is also going to have the API available on it. And this thing hasn't quite caught up, but if I build one more time. Right, now this, okay, I'm gonna name this actually to push now. It's to make this less confusing. So now everything is just called push. This builds, and let's see. This is kind of interesting. So in this case, we have the pool. We do one push into it. Then we have the iPool. We can even declare them like this. P, check. Nice. So we want to be able to do a push into the pool. We also want to be able to do a push into the iPool, and then that's going to fill everything up. Then we want to check that p.push doesn't work anymore, and iPool.push don't work anymore because they share the same data. So I'll just get rid of this. Looks like an abstract class in Python. So things are failing all over the place. Things are failing. Okay, because now m size is not getting constructed. So that's sort of the part where we need to come in here. Wait. Yeah. So, right. So now we're inheriting, and we're inheriting because we want to reuse this functionality. We need to make sure to properly set up the parent class before we do anything. And so that's what we do here, again, in our next iteration of things. I'm just going to quickly, I want to kind of save my work as I go. Whip one. So slightly broken states, but it's sort of cool to see the evolution of this. So first we started with just the very, very simple wrapper. And the downside was that the wrapper had all the logic and we couldn't actually call the methods on the actual class, which is a massive problem. And then now what we're doing is we're going one step further. Rather than having a wrapper class that's completely unrelated to this thing and just sort of as a lightweight view, we're actually taking advantage of inheritance to have them both inherit the implementation, which is going to allow us to call methods on either type. And let's just try that one more time. Okay, so that fixed some of these things, but now now it's time for another break, so I'll be right back. What's up? Olala8 in Twitch. So when do we rewrite it in Rust? Yeah, it's definitely on the roadmap. Probably in a couple years, maybe. It's a bit hard to tell progress with this project. I'm definitely interested, and I would love to learn Rust. I would love to write an operating system in Rust. But that's going to be for later. What's up? It's Dexter. Which OS are you using? I'm on Mac OS. Okay, so now what's going on here? So both we push into the pool, we push into the iPool, which are sharing the same data. Then why did this this fail? Let's walk it through. So, oh wait, is that right? Maybe this is kind of weird. We have the pool. Oh, yeah, it's because these two things are different objects. And yeah, so in this case, the pool has its own state. The iPool has its own state around the M index. And it's not actually a single shared state, actually. So right, so that's the problem. It's like currently we have this object, which is the pool, which has all this stuff inside of it. And we're separately declaring the iPool. Yeah, which gets pointers to the same data. Okay, maybe I'll start to like use some visuals. So we have like, dang, that's hard to see. So we have like a buffer of data, right? And we have the pool, which is kind of like the owner. How should I draw this? It's like the M objects array. The pool objects, there's also the M index, M or the P start, and then the M size. Okay, for the record, this P start should be called MP. And the pool sort of has all this stuff. Internally, it gets these things from the parent. And then this is in the child. But the pool has all of this stuff, right? Yeah, rectangle. Need it to not be. So this is our pool. And then what I'm doing, in my test, I'm making one of these the pool. But then I'm also doing something kind of weird. I'm making the iPool. And the iPool, it's like very similar, except it doesn't have this stuff, right? It's the parent class. And maybe just to illustrate it, the P start points here. But then the weird thing is that the p start of this also points here. And so they share this data. However, they have separate state. They have separate m index. And therefore, when I call .push on the pool, it updates, it like writes some data and then updates the m index over here. And then m index is like sort of pointing like a bit into this thing. However, this m index is still at the start. And then we call iPool.push. It basically overwrites the thing that the pool had just put in there, because this thing is still there. So the problem is that these two things need to share all of that state. And yeah, pool is for memory allocation. Yep. Yes, exactly. Pool is a type of memory allocator. But the characteristic of the pool is that it's fixed in maximum size. And so after a certain point, you cannot allocate from the pool anymore. Also, a characteristic of the pool is that it's for objects of a specific type. And so you don't ask it for a number of bytes like you do with malloc. You just ask it for a thing, because the pool is kind of specialized to give out objects of a very specific type. Right, so it's Ami pane, so pool, iPool, and check. So pool and iPool are these two types I'm prototyping to explore the idea of a data structure that has a fixed compile time size, but then also has a way to a corresponding type that can be used to operate on different instantiations of this concrete thing. So if we had a pool of size 2, 10, and 50, all allocated separately in the code, but we wanted to have a helper function that just did some basic helper operation and wanted it to be able to work on a pool of any of these sizes, that's the kind of thing we're doing now. Check is totally different. Check is for this unit test framework that I'm working with. And so so these are basically just some unit tests which allow us to write these very simple programs that just interact with the types and verify that they work correctly, and do that outside of the context of the main kernel. Okay, so we're getting somewhere though. And so the problem, right, is that the iPool maintains its own state. So the problem is that when we construct an iPool, when we construct an iPool from a pool, because that's how it works, right? Let me go to the ETL docs. This is a good time to check out the docs. ETL. Yeah, no worries. Ami pane. Yo, ETL. What? Oh, check this out. ETL got... I know they were working on some new docs. So... yeah, this is looking a lot better. So we want to find the pool, the iPool. And... or maybe the pool. Right, so... doesn't really talk about Okay, this is maybe a bit of a weak point of my C++ knowledge. So we have this pool type with this template thing. We can pass it into help functions that declare the iPool type. What actually happens there is that an object construction, or is that a sort of like object slicing kind of thing? Doesn't really matter. Let's just try to keep moving forward. But maybe this is kind of the wrong approach, actually, because maybe it's an object slicing kind of thing, actually. And so, so the idea is that we have some helper function, right? Or actually, no, I literally just coded it right here. We have the helper function, which is the iPool. It takes an iPool reference, and you can push some stuff into it. Right, helper push. So I'll call this helper push. iPool, nice. Got a pool, but it's a lot wetter than this one. Dude, I wish I had a pool. The only pools I have are these weird code things. So here's more the idea, actually. Let me see. This might have been just a wrong way to even represent this. Let me see. So let's try this. Check helper push equals -1. Right. This is a little bit more the concept, I guess. So we have the main pool. We can try to operate on it and see that it works. We can try to do the helper push and see that it also works. We can, and that at that point that has filled up, yeah, cute Kirby plushie, thank you. We can see that it has filled up the pool, or that's the last slot. Now we try to do a push from the original type and also via the helper, and we should see that they both fail. And we can just try to run the weird pool tests. And that's working, right? So I think that's actually more the way this works. You don't really instantiate an iPool per se, but you can use it in this way. You can probably even store an iPool. So that's because that's kind of what we need for our smart pointer. We need to let me see. So this is interesting. This actually kind of goes against a lot of this kind of typical C++ wisdom. This is a little bit weird because it is we're using a parent type without virtual functions. And so I think this is sort of doing object slicing. But I think it works actually. So we'll do an AI code review in 1 second. We can also look at ETL for how it does it. Yeah. So what's up, Ink Muse? Hardware and software setup for streaming. I'm using a MacBook Pro. I'm using OBS. Those are the main things. I'm using Streamlabs. Yeah. I'm using FMPEG to multi-stream to Twitch and YouTube at the same time. But I feel like it impacts my Twitch views because no one watches me on Twitch. So yeah. To ref. Make file. Do I have this make file thing? Host. Host. So I can build via VS Code also. So again, just to make sure this is really working, I'm just going to break the production code because I'm kind of paranoid. Build, run, that fails, good. So okay, so this is kind of working. We've proven the concept. It is this type that it's just sort of a parent class, and you can use it in helper functions, and you can even store references and sort of do stuff with it. And it works via object slicing, which is like a little bit weird, but I think it works, and I think it is also how ETL works. Let's let's take a moment just to try to read ETL. iPool.h. So there's ETL pool.h, right? And so these headers are pretty difficult to read because they are generic C++ libraries. But we can, for example, see that the pool is this class, and it's templated on a size. And I don't know, it has, there's some methods. Interestingly, it does not actually declare any members. And so it's pretty small. It's not doing super much. These things that, its constructor is also empty. That is pretty interesting. There's also this generic pool thing, which I don't totally understand. This is the thing that actually inherits from the iPool. And what it does is it does a similar thing. It constructs the iPool by passing a pointer to the thing. So we might need to do some of this stuff also for the real pool. So then the iPool The iPool is interesting. I'm not actually seeing a constructor because you don't really construct an iPool, I think. There's the protected constructor, yeah. And I guess that's what's used over here. So the pool itself does very little. Somehow I don't really. I'm gonna kill the palm tree. Also, we're running a bit late on time. Not really seeing where the parent class is constructed. Let's ask some AI. It explicitly call the parent class CTOR generic pool. It relies on the default constructor. Okay, yeah, so just some OOP. Right, so there's no explicit call, so it relies on the generic constructor. The generic constructor just runs, right? There's no real, yeah, there's nothing special about it. And then it's the one that's calling into the iPool. Yeah. And that's what is calling into the protected constructor for all this stuff, which is where it initializes this various internal state. Inkmuse. Liked your articles, especially read the assembly one. Ah, thank you very much. Are you talking about the set jump and long jump one? I think that's my main assembly blog post. C Nitro, are you building an OS on top of Linux? No, this is a custom kernel. Any comment on the future of systems programming with Rust? I think my only comment, I think Rust is a good language. I think it's a great language. So yeah, I think it makes systems programming a lot easier for a lot of things. So I think it's a great language. Yeah, but I'm not using it. So what I want to try, I think this is mostly cool. Well, actually, so it's different from my implementation. I was using the weird object slicing to do things. And I don't have, well, I guess I do have a constructor. No, I guess I totally do, actually. I totally do. So I'm just using this sort of implicit thing. But I guess it's actually pretty similar.
All right, so the way it does it, it's like this stuff is public. This stuff is private and there's a protected constructor. And the AI knows how to do it. It looks like this. This is pretty much the pattern. Very, very light wrapper. The actual concrete type is very light. It just declares the data and then sort of defers to the iPool, which actually implements everything and stores pointers. But to be very, very clear, this thing is only runs when you construct the pool. But then what about this stuff? This doesn't run an iPool constructor, right? So let's ask the AI. It doesn't run the iPool CTOR, right? This uses object slicing, right? Oh, what? No. Oh. Object slicing only occurs when you copy a derived object to a base object. So I'm using a reference. I'm creating a reference to the already created pool2 object. No slicing. The constructor already ran. Ah, even better. Okay. Right, so slicing is when I do this by copy, and I copy the pool into a new iPool variable, which sort of slices out the child from the new object. Here it's just getting a reference. That's cool. It's not even using virtual functions. So it creates a reference to the already constructed object. I see. Okay, so this is good. This is great. This seems to be completely working, at least for my kind of re-implementation of the basic concept of the iPool. And now that we've done this once, we can actually do this for real. And I am running a bit over time, but I'm kind of curious to see this start to work. Whip 3. And maybe we don't need to finish it now necessarily, but we can at least think a little bit about how it's going to work. Right, so to be clear, this pool and iPool thing that I was doing is just a fake toy example just to do a proof of concept of kind of this general concept of like the static size type with the iPool kind of like parent class kind of thing. And then we would basically sort of do that over here. With the challenge being that task stack pool already inherits from bitmap pool. But maybe this actually totally works. So bitmap pool is the parent class, task stack
pool is the child class. And the idea is to have some kind of task stack iPool sort of thing. I mean, the key part is that there's no additional data here. There is. This might be the hard part. So the idea was sort of to have this task stack iPool, but then this is sort of bad because we have multiple inheritance, which is bad. And so we don't want to do inherit that way. But then we can have the idea of the bitmap iPool. And we can do it this way, potentially. That could be kind of interesting. But would we really be able to use the bitmap iPool as a way to refer to this thing? I think this is where it breaks things. I think our custom free is where things break. We would need to introduce a vtable there to have that. And maybe we do, because like really this free doesn't do very much, but all it does is assert, which is not really the most valuable thing to do. And so actually I think this could work. So Afno Benzene, what's up? What's up? Yeah, you are late. We're probably gonna wrap up the stream pretty soon. But yeah, this is kind of interesting. And so based on what we've prototyped so far, I sort of can't resist bitmap pool.hpp. So let's duplicate bitmap iPool. I mean, we don't even really need to. Oh, Duke fell asleep. Well, sleep well, Duke. Sorry you find this boring. There's probably some other YouTube content that's interesting. Yeah, we're sort of in the nitty gritty today. And so, so here's the concept. The concept behind all of this is bitmap except this is not right. Bitmap iPool is a type that what's with guard pages update, if I may ask? That's exactly, yeah. I'm glad you asked. That is exactly what we are continuing to work on. So last time we basically got the very kind of initial version of guard pages working with this custom pool allocator for the task stacks. But then I tried to integrate that into the rest of the kernel. And the problem was that the rest of the kernel expects the pool to provide a smart pointer type. The task expects that there's a smart pointer for the pool. And that was true when I was using that old pool that was broken, this ETL pool. But with my new pool that was like actually working, I don't have the smart pointer type. And so that was the challenge. And I was working on implementing the smart pointer type, which is where I ran into another problem of this exact thing we're working on right now, which is where the smart pointer type relies on the ability to have this sort of like iPool kind of type, which is kind of like type erased. Usually the pools have a template argument with like a fixed size, and the iPool type erases that type argument, which allows you to reference a pool of any size. And this is important because the smart pointer needs to hold one of these type erased pointers. And so the smart pointer depends on having the iPool available, this iPool concept available. And that's exactly what we have been doing this stream. It's sort of like prototyping and understanding how you in general create an iPool, and then literally right now sort of like trying to apply that. Yeah. Ray, for the uninitiated, could you explain the smart pointer concept? Absolutely, yeah. Smart pointer, really, really quick. I mean, the basic idea with a smart pointer, it's sort of talking about, you know, in C code, you do like malloc, and then later you need to do free, right? And you do this manually, and you do a function, right? And so this is like how you do it in C. This is not a smart pointer. This is a dumb pointer. And so the problem is you need to really remember to free. And in this, you know, it can get very complicated to remember to free everything always correctly. The innovation introduced with C++ is you no longer do it this way, but when you conceptually call malloc, you get like a smart pointer T type. And then, you know, stuff. You can use it in the same way you use the regular pointer, but you don't need to remember to free it. When it goes out of scope, it automatically calls free. So, and it does that via the C++ language feature of destructors. This is also called RAII. And that's the basic concept of the most basic kind of smart pointer. There's other kinds of smart pointers. So what I've just described is the most basic smart pointer, which is called a unique pointer in C++. It uniquely points to one thing. And so the nice thing is you can never forget to free. It will always free it. So yeah. And what I'm doing with my project is I need to make my own smart pointers. Like usually C++ comes with smart pointers available for you to use, but I'm not using a lot of standard C++ library stuff. And so I need to make my own smart pointers. So you need to fix your pool structure for pointer types. I need to I need to expand my pool structure to support the iPool concept, which is necessary to implement the smart pointer. The idea of this type erased iPool is important for implementing the smart pointer, because otherwise this template argument of the size just spreads like a virus. It just infects everything becomes a template if I don't type erase it, and it's like super annoying, and even like it is even bad design to have the template argument invade and like proliferate to such a degree. So yeah. Between your Discord today, lots of amazing projects going on. Managar, Monolith Shell. Yeah, there's a bunch of cool projects that people are working on in my Discord, for sure. I'm really proud of them. Yeah. Yeah, for sure. What's up, Musty? What made you want to build your own OS? Sorry if you've answered, I've just discovered your stream. I mean, I'm just really curious about learning about OS development, and I was always just so curious to try my skills and try to do it in C++, which is a language that I'm pretty comfortable with, and just see
how it would look like if I did it in modern C++. Yeah. Yeah, I'm also interested in learning more about sort of like embedded style programming and stuff. So the idea with the iPool idea is you no longer declare the actual data. In the iPool, you declare pointers to things. And this is actually interesting. A problem that I didn't have before was the T. Because I was hard coding it to be an int. Okay, I'm gonna cheat and look at what iPool doesn't even type the buffer. That's really interesting. It's really abstracted. I think I don't want to do that. I think I will actually do it slightly differently, and I will actually make this a template, which is still okay because the main problem was the proliferation of the template size parameter everywhere. It is much less of a problem to have the iPool be templated just on a type. Could do it ETL style and not even have this be a template. Use a raw char buffer, but it's a bit easier to do it with this style. And so the idea is then you have a protect. No, this is private. You have a iPool. With this pattern, right? And then over here, you do this so the AI sort of knows what I'm trying to do. And then over here, we just need to the bitmap allo. So that's also sort of this deal. So that adds a complication, actually. What's up, Sultan? How many years of experience do you have in C++? I would say I have about 7. This complicates things in kind of an interesting way. Because now this parent class is not only operating on this array of data. It's operating on this bitmap allocator for which it doesn't really, dang. So basically we need to also, I think, we need something, we need like this, we need like also a type erased version of this. Which I think is possible to do, but it sort of, yeah, it sort of proliferates a lot. So then now we need this sort of bitmap allocator kind of thing. And it's going to be the same pattern. Instead of directly storing the bit set at a fixed size, it's going to be this class that stores some, I guess, yeah, it's going to store a pointer to the start of a bitmap, and then keep track of the length, and then implement all those operations. But that's actually that's actually starting to get kind of difficult, because that it potentially means we need to copy paste, I don't know, some code from Frig. So that it's kind of annoying to make that also, actually. So this is getting a little bit hairy, getting a little bit difficult. I am curious. I thought that ETL also had I thought ETL had bit set. ETL does have a bit set. I don't think it has an I bit set though, which is sort of what we need. No, right? How would I even find it? I don't really know. Utilities. It's that new. Okay, yeah, this is getting like kind of deep. So recap, what did I learn? It might be possible to have a bitmap iPool, which means getting rid of the custom free with the assert in task stack pool. But that's okay. It's not that valuable. But it's tricky to do the bitmap iPool, because we not only do we have pointers to the pool data, but we also need a type erased view of the bit set. And that's difficult to do. There's no frig I bit set or ETL I bit set. So so that is a little bit of a tricky roadblock, and I think I'll have to think about how to solve that. Yeah, there's not a lot of great options. Option, patch, rig, and add an I bit set. Possible, but very not ideal. Yeah. Yo, Tugra, what is up, man? Nice to see you. Mix all three. Yeah. Ooh, this is an interesting problem. Yeah, I'm running into all of this just because I want to have a statically allocated pool of kernel tasks, or sorry, a statically allocated pool of kernel of stacks.
where I can unmap the guard pages all up front at once, and then kind of allocate and free the stacks as the tasks get allocated and freed. And I want a smart pointer for that. And it's kind of difficult to do that with this pool, with the bitmap pool. It's a little bit of a, unlike the ETL pool, bitmap pool is a bit of a more difficult type to type erase. Yeah. I'll have to think about that. All right, guys, I think I'll need to wind down the stream, actually. Yeah, this was very interesting. We're making progress for sure. But this was a very interesting roadblock to hit with all the pool stuff. So yeah, still working towards my goal of having a really solid guard page implementation, and it's so close, but this smart pointer thing is interesting. It might be another way I can do it. There definitely are other ways I can do it. I just had a weird idea. And a lot of my problems are coming from the fact that I'm using a bitmap for the bitmap pool. That is not the only option. Problem is largely due to using a bitmap for the custom allocator, which is hard to type erase. A solution is to use an alternative. I mean, such as an ETL pool. That's weird. Like ETL pool? Yeah, so I don't know if where my diagram is, but basically the idea is, okay, so the way the custom allocator works is there's the big chunk of data for the stacks, and then off to the side we have a very little chunk of data for the bit set that tells you which of these stacks is free or not, and it just sits off to the side, and its purpose is just to be a very simple metadata that sits out of line from the main data. And another way to do it is the stacks are there, but instead of a bit set, we actually use an ETL pool. Technically, it's a bit set allocator. Alternatively, we use the ETL pool. All right, lost my chat. Do you think this is why the ETL pool isn't typed? The ETL pool is typed. It's just the iPool that is like very untyped. Yeah, so just to sketch it out, and this will probably be one of the last things we do today. So the naming of this will then change. It's not a bitmap allocator or what the, yeah, sorry, over here. It's no longer a bitmap pool. So here's where we have the main storage for the objects that corresponds to like this big block over here. Then here, this is the thing. This is that little out of line storage. This is the bitmap allocator corresponding to this stuff. And the idea would be to actually not do the bitmap allocator, but do an ETL pool of Boolean and T size or something like weird. And it is conceptually the same thing. It's just like a set of bits that, I mean, we don't even really need storage. All we just want is a way to have like n number of things, um, kind of just like allocate out of that n number and then release things back to that n, and then just be able to do that. That's really the only requirement. All we do is we need to be able to allocate a thing and get its index into the of what kind of element it corresponds to. Which I think was kind of hard with ETL. I think it's definitely doable though. I think yeah, it might be a little bit sketchy, but I think you can do it. So the reason this would be a solution is because unlike the bitmap allocator, which we don't have the type erased I version of it, we do have the type erased I version of the ETL pool. The problem with the ETL pool is it's much less memory efficient than the bitmap allocator. The ETL pool uses a free list, which has all these pointers and stuff like this. And the idea is that this T size should be kind of big because it's like corresponding to every task. Hmm. Yeah, I don't know. I want to think more about this. This is kind of tricky. It's also kind of interesting because the tasks themselves are stored in this like static linked list, and so each task has an index into that, which maybe I can use. All right, guys, I'm kind of burnt out. I think I need to call it for today. How far are you with OS? Approximate percent. It's impossible to really say. I can only say I'm in pretty early stages of it with the core infrastructure. So yeah, it's not really. I'm still working on the absolute just core infrastructure of it. Apnobenzene. A pool is just a certain type of memory allocator that offers a fixed capacity, a fixed size, and it is specific to basically one kind of type. And so it can give you an object of a specific type. It's not general purpose in that you request a number of bytes from it. So yeah, thank you, Ray. Appreciate that a lot.
This is a very interesting challenge. It's been a while since I really um, got kind of locked on this, but I hope it's at least kind of interesting just to hear me think about how I go about solving it. I hope I know it's very deep and hard to understand. I apologize. It's just so niche. But once we get through it, I can make a better explanation of the whole journey. So, yeah. We got Sultan posting some code in the chat. Yeah. All right, guys. Thank you very much for joining. My one request is that if you are enjoying this content, if you are not subscribed to my YouTube channel, please subscribe to my YouTube channel. That is very helpful for me and is the best thing you can do. So thank you very much. Adshar, I am an embedded systems engineer and C++ engineer working in the music technology industry. Yep. All right, with that, that's going to be the end of today's stream. Thank you very much. And I'll be back at it next week and we'll dive right back into this very interesting problem, which I will hopefully be able to explain better. Have a great week, everyone. I'll catch you next time. Peace. Peace. Yeah, there we go.